I have nothing written on the board. So what's the question we're going to do today? That's actually because the question is written on another whiteboard, because this question is very long. It's a word problem, but it's also quite difficult. So what makes this question very difficult? Well, this question is actually in the O-Level A-Math Paper 1 in 2025, and this is actually the very first question you see. So what makes this question very difficult? Let me first of all read the question and explain it so you can understand. So it says that the item is to be sold online. So at the start of the very first month, it is placed on sale at an initial price of $300. And then at the end of every month after that, 5% of the price will be deducted. So, and it continues to be sold at that price. So the item is then finally sold when the price first drops below $120. So the question is asking, how many months have passed before the item is sold? How many complete months have passed before the item is sold? Okay, so by the way, if you see me looking down there, I'm not staring at my floor, I'm staring at the question. So I put more about that. And for the viewer's sake, I'll probably put the question like up here maybe, so that you refer to it whenever you want. Okay? So first of all, we need to understand what to even do, because usually for word problems like this or real world context questions, they will give us a mod, like an equation to follow, and usually it will be a part question so that the marks are divided. By the way, this question is a whopping 5 marks, and it's the first question, so it is very, very intimidating. But let me break it down. So the first thing I notice is that, well, it seems to be that the price will decrease lesser and lesser each month. Why? So let me first visualize this by drawing a table. So let's say this is the month, right? This is the month, and then this is going to be the price. So on the very first month, nothing happens to it. It gets sold at its initial price at $300. Okay, then at the second month, 5% of it gets deducted, and so we will now have 95 over 100 times 300, which is 285 if I am not wrong. Yeah, I'm correct. So this is the price of the item on the second month. On the third month, is actually 95% of that. So 95 over 100 times 285 will give me 270.75. So we can already see there's a pattern. From here to here, the decrease is minus 15. But from here to here, the decrease is a 5.25. So the decrease is gonna go down exponentially. In fact, the graph, if you were to draw a graph that models after this equation, it will look something like this. Right? It will look like, so 1 is here, 2 is here, 3 is here. It will look something like this. And let's say this is 500, so obviously we know that the starting point is here. It will look like that. It will be an exponential like that. Because because right, and the reason why I know this is because if you notice, right, we are taking 95% of the previous month's price. The thing is, because percentage is based on the value that you're taking the percentage of. 1% of 100 is 1, but 1% of 10,000 is 100. So the 1%, don't underestimate it, because 1% might be a lot. It depends on what you're taking 1% off. Okay? So applying that, what I just told you to this, 95% of 300 is a lot. 95% of 285 is not that much anymore compared to this. So as you go down, the price that you're having here is gonna be getting smaller and smaller and smaller. So because of that, the new price is going to be less, like, it's gonna be closer to the original price, because the less of it is gonna be deducted. So because of that, we can tell that the price does not go down in a linear fashion. Okay? So what if it doesn't go down in a linear fashion? That still doesn't help me answer the question. We are just observing the general trend. Now, time for the first revelation that I had in the exam. So I would like to introduce a concept to you called reverse compound interest. Now, first of all, what do I mean by this? Now, let me first recall your memory of what compound interest is. If you don't know, compound interest versus simple interest. Simple interest is that there will be a fixed amount getting deposited into your account, let's say every year. So let's say it will be $300 per year is a fixed amount. So 300, 300, 300. So that's very easy. But most banks don't do this because if I know what I'm getting, no matter how much money I have in my bank account, I will still get $300. But it's a percentage of your principal amount, which is the amount that you first put in. But for compound interest, the amount of interest you receive at the end of the year depends on your total amount in your bank account. So if you don't know already, the formula for compound interest is A equals, it might be A, I think it's A. P times, P is your principal amount, 1 plus R over 100, which is your rate, meaning how much based on your principal amount is going to be deposited to the power of n. So let me break this down right now. Why do we have a 1 plus R over 100? That's actually because if I say that, okay, 5% compounded year per annum compound interest, right? This means that, let's say, right, we don't care about the power to the n. First I will explain what it means. So, what I mean is that at the end of the first year, I will get 105% of my current principal amount, right? So that's why if I have, let's say R is 5, right? So this will be this 105 over 100. Why did this come from? Because 1, we can express this as 100 over 100. So then therefore, this will actually just be 1.05p. Makes sense, right? Because you have 105% of your principal amount. But the reason why we have the power to the n is because every single year it gets multiplied. So let's say we don't do that. So this is the end of the first year, right? Then the end of the second, let's say it's A1. So this is the amount you have after the first year. Then the second year, A2, is therefore going to be 105 over 100, 105% of this amount of A1. Because the amount that you have, again, like I said, in compound interest, the amount you will receive is dependent on the amount you have at that present moment. It doesn't care how much interest has been deposited already. So because of this is the same thing as 105 over 100 times 105 over 100p. So because of this, the 105 over 100 gets squared. That is why we have the power. But another way to look at compound interest is there's an exponential increase in your money. Of course, let's say you put $300 inside and then you leave it there for 10, 20 years. That number is going to skyrocket because of the compound interest. So that is what I call the exponential increase, meaning that at first it won't be so much, then as you leave it skyrockets. But in this case, we're talking about the reverse compound interest, where the number is actually getting smaller and smaller instead of increasing. So let's take a look back at our question, right? It says that at the end of every month, if the item is not sold yet, 5% of the price will be deducted, automatically removed, right? Which means that instead of having a plus here, we need to have a minus. So the formula that we are actually looking at, or that we have to come up with ourselves, is that the price, let's say this is price 1, right? Or I should say, okay, I don't know whether it's PN, meaning the price after the nth month, or at the end of the nth month, because you see at the end of the month, then it decreases. So at the end of the nth month, this is the price. The formula is P times 1 minus R over, okay, in this case, we know the R is 5, right? 5 over 100 to the power of n. Now, why is this work out very nicely? Because 1 minus 5 over 100 is just p times 95 over 100 to the power of n. So if you don't believe me, you can try to put the table yourself. And then you can try to plug it in using this formula. So let's say principal. Principal we already know is the 300, right? At the start of the first month, the price of the thing is $300. Then 95 over 100 power n. If you plug in 1 for the n, you will get 285. Plug in 2, you will get 275.25, I think, or 275.25. You will notice that this equation correctly models the table we did earlier. This is why a strategy that you can do is, if you see like a word problem and then you don't know where to start, you don't even know what, and they don't give you an equation, a good idea is to have a table of like the trend so that you can later see how you can apply what you already know to this situation where it's not so straightforward. Okay, so we have successfully come up with an equation to help us tackle this problem, and we made use of the so-called reverse compound interest. I say reverse because it doesn't actually, I put the quotation marks because technically there's no such thing as reverse compound interest. I mean, come on, you can't be depositing your money in a bank and having the bank take away your money. That doesn't make sense. So that's why it's an easy way to understand it, because it's a reverse in the sense that there's a decrease instead of an increase. So Pn equals to 300 times 95 over 100 to the power of n. So how can we use this to solve our equation? Let me clean this up first. Okay, I've written down the formula. So the question, if you read on, it says that the item is sold when the price first drops below 120. So we have to form an inequality, that's right, an inequality for this, right? So this means that we want the price to be below 120. So this entire thing has to be lesser than 120. So 300 times 95 over 100 power n. The entire thing is lesser than 120. So from here on out, you might be intimidated by this inequality, but actually, if you notice that whenever we have an inequality, for the most part, we treat it like an equal sign. Only when we times or divide by a negative number, then we flip it. So for the first part, right, it's quite straightforward. So you divide by 300 on both sides. 95 over 100 to the power of n, which is over 120 over 300. So before I do anything, let me simplify this a bit. This is 19 over 20 power n, and this is, I believe, 2 over 5. Am I correct? Yeah, I should be correct. So after you do this, right, if this was an equal sign, then your life is safe, because now you need to log both sides, right? But then there is a question, because right, log, the property is quite weird. When it's a fraction, it's a negative number. So the question becomes, do you need to flip this inequality sign when you log both sides? The answer is no. Why? Because, right, first of all, we need to take a look at the y equals to log x graph. Alright, let me draw the graph over here. The graph of y equals to log x looks something like this. Actually, this one will still have an increase. So yes, this is the graph of y equals to log x, and this point where it crosses the x, where the x-intercept is actually 1, 0. So right, this tells us that anything before 1, if it's a fraction, if it's a proper fraction, then the value will be negative. But that still doesn't answer the question. How does that tell us that we don't actually need to flip the inequality? Well, that's because 19 over 20 is somewhere around here, very close to the 1, but not 1. 2 over 5 is around here. So if we know that 19 over 20 to the power of n is less than 2 over 5, then we know that log of this is still going to be lesser than log of this. I know the power is quite confusing because we've seen that 19 over 20 is here, 2 over 5 is here. But remember, when you raise a fraction to a power, the value of the fraction decreases. So for example, half to the power 1 is 0.5. Half square is 0.25, because this is 1 over 4, right? 1 over 2 cubed. This is 0.125. So, moral of the story, if you increase the power of a fraction, the value of the fraction decreases. Okay? Because the denominator gets bigger. So, if we have 19 over 20 raised to some power n, this n is enough to make it so that this entire value of this fraction is lesser than 2 over 5. So, in fact, we can keep the inequality sign. So, I'm going to write this here. So, we have a log of 19 over 20n, which is lesser than log of 2 over 5. So now we can do our usual business. This one bring it to the front because of our logarithm rules. And log of 19 over 20, this is less than log of 2 over 5. Now we need to then divide our log 19 over 20 to the other side. But notice what I said just now. This is a negative number, which means when we divide both sides by this, we are dividing by a negative number. That means that we need to flip the inequality sign. So our n is, when this is true, when the price of the item is below 120, our n is more than this ungodly fraction, log of 2 over 5 over log of 19 over 20. Which that if you type it in your calculator, you will get that n is more than 17.864. So the period of time where the price of the item falls below $120 is when when about 17.864 months have passed, and so on. And from then on, the price never comes back up. So what's the answer? The answer is how many, the question is how many complete months have passed before the item is sold. Note how the question did not ask how many months have passed or what is the month that the item is sold. How many months have passed from the start so that the item is sold? If that were the question, the answer would be 17, I think. That's what I put. In fact, I got this question wrong because I misread the question, so I ended up getting this. I'm like, oh, n is 17, done. But this is why you need to be very careful with reading the question. How many complete months have passed? If you put your answer as 17, no what? This is more than 17. So if by the time 17 months have passed, it will be at the 17th month. This still hasn't been sold yet because it will still be slightly more than 120. But the 18th month, so 18 months have passed, it will be already more than this, so it will be correct. So it will be more than this, which means that the price will be lesser than 120. So the answer is actually 18 complete months, which is the answer. So yes, this question is very difficult in the sense that you are not given with much information, yet you have to derive certain things using this information alone. So you need and you need to make use of them properly to get your answer that you want. And I would say this is also a very difficult question because this is question 1. For God's sake, this is question 1. It's worth 5 marks, and I would feel that, you know, if you are not that strong in math, especially A math, this question would have killed your morale if you were taking that question, if you were taking that paper. Because that I noticed that, I said this in my previous video talking about the cubic factorization question, that the beginning of the paper was exceptionally difficult. But then as you go on, and paper 2 as well, the questions got more simpler and more straightforward, more like the types that you see whenever you do your practice paper, your prelim papers. So don't be intimidated by this question. Although yes, it is difficult. If you really can't do it when you see this, when you sit for your O-levels, don't worry. Skip to the next question. Worry about it later. Because I noticed this not for this paper only. There were a few TYS papers that I did where the first question I didn't understand what was going on, and then I flip over, oh actually it's not that difficult. Alright, so yeah, that's it for this video. Hope you guys enjoyed it. If you did, make sure to give this video a like and comment down other questions or what other things I should do, because I'm running out of ideas. I've covered a lot of the hard questions in the O-level for last year. Tell me if I should do the other O-level years as well. Alright, that's it. I'll see you guys in the next video. Bye bye.